Welcome to Dr. Spotfire session. I am Dr. Vishakha Mujju. I have my colleagues Divya Jyoti Rajdev, and we have our featured speaker, Peter Shaw, with us, who is a principal data scientist, and he has been an alumni from MIT and and he has been kind of very instrumental in kind of helping our clients with R, and he has kind of covered all the verticals. He will be talking about exploratory data analysis in maps. So once again, learning is not driven by answers, but by questions. So we encourage you to post questions with hashtag Dr. Spotfire. And I have my campaign architect, Alexis, with us. So we also found that some people are having signing up issues. So please feel free to contact her regarding any issues with the sign up. We are based out of Palo Alto. And let's go ahead and get started with our featured session, Exploratory Data Analysis with Map Chart Visualization. Can you pass the ball to Peter?
All right. Well, great. Well, thank you so much. Good morning, good afternoon, wherever you are. Thanks for joining us. I'm going to be, let me just share my application. I'm going to be talking about mapping and various tools we have in Spotfire for analyzing data in a geospatial sense. And the data I'm using is a sample set we analyzed recently. It's basically U.S. traffic fatalities. And the interesting thing about this is that, you know, there are obviously the major population centers is where the fatalities tend to happen, but also along these highways and stuff in between major cities, all these interstate kind of things. So there's an interesting pattern there. There's also some interesting time patterns, time of day, day of week. There's actually a very rich data set. This is from the National Highway Safety, Traffic Safety Administration, and it's just to have a really very rich data set. So let's just start off with just, you know, I can just plot the points here in Spotfire. This is actually obviously a layer in the mapping visualization. I've got the base map layer, the accident data, just these points on top of the base map, and I can then use filters to say, you know, this actually is years 2010 through 2015, I believe. Yeah, so I can see, yeah, I can look for patterns from year to year, obviously with filters. I can look for you know, hours of the day. Here's accidents that happened early in the morning and middle of the day and so forth. So, you know, there's all those kind of active filters. But one of the things about this presentation is, you know, I can zoom in and everything, but there's some, you know, pre-concentrated points, and it's still not exactly the most easy thing to see if you're looking at just where the most dense points are. Once it gets totally black, within that structure, maybe there's some other stuff you're not seeing, or especially if you zoom out, you know, when it's just totally filled with points, you just have a hard time seeing any detail. So you need some additional tools to see what's going on there. One of the tools I can use is from our TIBCO community site, the text bin data function for Spotfire. Text binning is a tool used in the R environment for a long time. It's just the actual DXP file you get, and the idea here is I've got a base. This is just made up data. It's just made up XY latitude longitude data with some kind of third dimension, and the top two panels show the actual spatial distribution of the data points. This is just like literally just the distribution of the data points, and the one on the right shows the data points plus this third, let's see a bit better, I zoom out. I've got a third field of something. Again, I just made it up with some random number generator. So And the thing is, if you do that, you might want to say, I want to do some kind of like interpolation or averaging within this. So the hexbin can do two things. One, it can do, well, first of all, it sets up this hexagonal pattern of bins. And I'm just plotting these with points right now in Spotfire. I can use those to show the average value within each hexagonal bin or the count. And in this case, with the accident data, the count's going to be the most important thing. By the way, you can get that from the TIBCO community site. Exchange is a whole entry for the hexbin thing. So on my next page, I got the hexbin basically applied here. The way this works, if I look at my data functions, I've got this hexbin function already plugged in there. The parameters I need, it wants to know the X and Y coordinates of each of the individual points. Optionally, there's a value, like a third dimension. I'm not going to use that. There's a number of bins. I think it's a default value. I'm putting a pretty large value here, 200. And there's some kind of verbose switch for if you want to see interesting output. And then basically the main result is hexbin result table. So the way I have this thing set up is that basically all the points now are shown in, I think it's white, so they kind of fade out. But now if I grab a section here and highlight them, it's set up so I've got the data points I mark. Those are the ones which go to my hexbin data function. So I can see, you know, again, it's not super, but I do see some, I can see kind of into the details of these geographical regions a bit better. I can actually see, you know, the points don't overlap. I can adjust the size of those things and they don't overlap. So this is a nice way of kind of seeing a bit more detail. And this is interactive. So again, if I just grab a different region here, I can have that update and so forth. And the way that this is actually, I should point this out, data function, hexbin, I do have this set up so that it is aware of my marking, and I do have it to refresh automatically here. So with these two things set, and by the way, X and Y both have to have the same filtering, otherwise they'll be different lengths, and so it'll give you, you know, there'll be problems there. But you know, right now it's set up so it just refreshes automatically, which is great. You know, I can see details and so forth. Now, the next couple of pages are let's see. So one thing about this is that there's, you know, I have to adjust the size of the markers and so forth, you know. So another approach to this is to have this kind of grid here. And this is a grid actually I created, and I'm planning to put this up on the community site shortly. It's not quite there yet, but basically the grid here is just a simple grid. It's essentially a shapefile. And the way this works is that I have basically it's a data function. So I have a data function which comes basically, it works hand in glove with this shapefile, right? So this basically creates a grid ID. So what it does, it takes my original data table. I put in my X and Y values. There's actually a third thing for my, I've got a name for this thing because I, you know, actually had a different one with a more coarse thing, but it basically does a quick calculation of how to calculate the grid ID, and the output is basically this grid ID column, which gets appended to my main data set. So if I link it by that, I can essentially aggregate this by the number of points inside each thing. Let me just quickly show you. It's just a very simple calculation. The grid ID, edit scripts. I'm essentially doing some little boilerplate stuff at the beginning, some default values. But what it does is it's just simply calling these indices. It's basically doing this offset kind of binning calculation and essentially computing these indices and computing this grid ID column to go back into the data set. So the nice thing about this is that this actually is a representation of the original data set. Each of the, this is actually a feature layer. So if I look at the layers, this is a feature layer. I'm actually showing the grid as its own layer, but I'm coloring this by the count of just any column but an individual data set. So what my point is that as I move these filters around, this actually will filter and update live. So I can see the same kind of patterns, you know, as with the point data, but I'm seeing this now as a nice colorized map here and everything. And I can do the same thing here. Let's look for where the fatalities are, the early morning hours, the middle of the day, and so forth. And you know, you can kind of look for any patterns. And you know, if this is just the one data set, but if there's other data sets, this would be a way of exploring the data. So I'm basically in exploratory mode right now, right? So I have a data set. It's pretty big, pretty complicated. I might be looking for some patterns. I'm just exploring, and this is one tool I have for this. Now, I wanted to talk to you about, again, let's just take a look at how this is set up inside the layers here. So here's my layer. It's the continental U.S. grid I've created. It's a feature layer. But the thing about this, let's just choose a some year here. So the thing about this is that the empty cells are still shown here. If I click on this empty, if I can do this, yeah. So it kind of shows me these are all the cells that are empty, and I would really like them to be transparent and not this blue. I've got some transparency on the overall map, but the blue is still showing as a blue color. It would be cool if that would be transparent. So I do have that here as a transparent map, and this has some advantages because, let's let this refresh. Come on, little guy, you can refresh. Oh, you know what? I think I have some marking going on here. Is that true? Oops, there we go. I've got different pages and they'll kind of talk to each other through marking. So here's that thing, and again, if I update this page, I get the same updates, but now only those cells which actually have more than zero things are showing up. And if I zoom in, the ones which are not in use effectively kind of drop out. So that's pretty cool. So the other way, so the first way with no transparency is the way like I've been using for like a long time. You basically drop a layer into your map. It's a feature layer. Here, by contrast, if I look at this setup, I have one layer, but now, so accident is the name of the original data file with all its points in it, and it's no longer well, it's actually coming in as a feature layer, but it's the points to the accident data set. And what I'm doing is that the geocoding, I'm actually kind of matching this grid, that grid ID right, I've created, kind of talks to, it knows about the grid ID in the shapefile. There is it's basically a column match, right? So it's a column match like we always use in Spotfire. You match columns, and then you can borrow information from a second data table in a certain visualization. So the advantage of this way is that by setting it up this way, that's where you get the idea that you get effectively transparent portrayal of the data because only those points which are showing up are shown on the plot. So here's the plot. Here's the plot. I've been using this for years. This kind of standard, if you will, plot. Here's the plot, setting it a little bit differently, and it's very cool because it all drops away. And especially if you have like, imagine if you have like a big storm system coming on. Basically, you might want to show some data in just one region and just see the regular old map everywhere else, or you could have a couple of different layers. You could have different competing, dueling layers here. So there would be, some pretty interesting visualizations possible there. So I am using a shapefile, and I thought I would show you, here's this thing. So a shapefile, I have this county shapefile from the U.S. Census Department. You can grab these shapefiles of states and congressional districts and zip codes and block groups and stuff like that. And one thing I thought like showing is, so shapefile, let me just see if I can show this here. Shapefile, here's my grid, which is pretty boring here, but if I look at the county shapefile, each of the shapes here is the shape of a county, so that's kind of cool. And that's coming in, so the name of this column here is called geometry. I don't think that the name is important, but it's got some coding to let Spotfire know it actually has a geometry. It's got some unique identifier, information, blah, blah, blah. So one thing like this kind of fun to demo is if so here's my data viewer on the left-hand side. If I grab that geometry column, right, and drag it over here, what happens is that here's your series of targets, if you will. You know, color, size, these are all kind of dimmed, but there's this last one which usually never appears, which is geometry. So if I drop it there, I'll now see my shapefile, which will basically kind of obliterate everything else, show up on my map. So the shapefile contains Alaska, Hawaii, and everything like that. So, and it actually, interestingly enough, it shows up behind the it kind of tucks away in the second thing there, so it's behind the accent, so it's underneath the thing, which is interesting. If I turn this off and kind of see, here's your, you know, you've seen this a million times, the counties. I don't have this linked, so it would be cool to, you know, I can obviously link this and color code the counties by the density of points by looking at the appropriate name of the county and so forth, but I just don't have it here. The map is kind of a nicer, I think, in some ways, approach because the grid here is even across the entire country. There's no, you know, if you look at the counties, clearly in the western states, they're bigger counties. Turn this off for a second. You know, there's an obvious distribution of sizes. I mean, it's very cool to see the shape of the counties. There's a lot of cool stuff there. But for a objective view of just the straight up density of points, some kind of grading thing like a hex bin is good, or this grading thing is good. All right. The kind of last thing I wanted to show you is this idea of heat maps. DJ was pretty interested in this one. DJ and Vishaka, when I showed him. So this example, let me make this a bit smaller here. So these three crazy heat maps here on the left-hand side is using the information about time of day. So let me actually just show you guys. So here's the accident data from the FARS, the National Highway System data set. It's got a lot of codes. It talks about a lot of cool stuff, actually, what time the vehicles are, anyway. So if it was clear, cloudy, it was daylight, et cetera, et cetera, et cetera, all kinds of cool stuff. But there is the hour of day, day of the week, month of the year, and so forth. And I'm making these heat maps. Well, first of all, heat maps by themselves are kind of cool, but they're also linked to the actual data. So if I just grab some data on here, it'll show up on the map. But to talk about the heat maps for a second, the top one, I just made this like yesterday, and it's like, holy moly, these are, this whole shape here is raised. And so the redder, the warmer colors show where there's more dense information. So across the x-axis is the month of the year. So here's January, February, March, and so forth. And here's the hour of the day from midnight here to noon to, you know, the evening hours and midnight again over there. It kind of wraps around. And what's interesting to me is you can obviously see the commute time. So this big red blob here is the commute time here. What I had not seen before is this kind of smile right here, which is people going out. They're staying out later in the summer because of like the days are longer. It's like, wow. I mean, it's the overall proxy for patterns, right? So it's kind of series data set, it's talking about fatalities, so I should keep that in mind. But it does show the overall pattern of behavior that people do stay out longer in the evenings in the summertime, and they basically go back home and everything. In the winter time, they don't stay out longer. But there is an interesting pattern here that there's the afternoon commute and the evening activity where people go out again in the evenings. These other two panels show the months on this axis, so January, February, March, and everything along here this time, and day of the week. So there's a lot of fatalities on the weekends, Sunday, Friday, and Saturday. So there's a lot of fatalities there too. And especially if you look at the hour of the day and day of the week, the fatalities occur in the early hours of Sunday morning and Saturday morning, and the late hours of Friday night and Saturday night. And there's another coding for if alcohol was involved, and that's exactly where the alcohol is involved with these situations there. So one thing I was looking at is that if you highlight some of these early morning accidents, they're basically clustering around around basically the metropolitan areas, whereas if you look at the ones that happen sort of across the board in the middle of the day and middle of the afternoon, that's where you get the patterns that show up that people are actually engaged in these like cross-country trips and everything. So it's an interesting observation that, you know, these are fatalities. So people who are involved in fatalities in the middle of the day, those are the ones who are in the middle of these cross-country trips, whereas the ones who are the fatalities who occur in the early hours, probably involving alcohol, in the early hours of the day, those are not people who are engaged in these massive cross-country trips. They're ones that basically cluster around their localities there. All right. So yeah, so basically there's a number of tools we use in Spotfire. These link drill downs are really useful for interacting with, you know, you might want to say what's up with this area right there. It does highlight the different regions in the other maps, but also you can see in the drill down of you might want to investigate some hypothesis or whatever, you know, some region that is of interest over there. So that's all I got. And I guess so yeah, summarize how you map from the point locations to the hexagonal binning kind of situation where you can use this binning thing to refreshes there, to the maps with the no transparency, maps with the transparency, to the way the generic shapefiles are put together, to these heat maps. Good. So I guess we'll be collecting questions in the chat, and let me just pass the control back to Shaka here.
Thank you, Peter. That was really very interesting presentation. So let me share my screen. So these are the questions we will be kind of discussing today. So there was one question which I received on an email. So once again, let me remind you, either you post on community with hashtag Dr. Spotfire, or you can send us email directly. That's how we kind of pick questions, or based on the similarity of questions to our topic, that's how we select our questions. So in this question, there was no data provided, but still I will be able to kind of walk you through the solution. So in this case, we have two values. So there is a global value, which is in this case a p-value, and you want to color the bar for a particular day in red when it is more than that global value. Otherwise, you want another choice which is coming from the data itself, like the mean of waiting time by day. So you want to color based on the data values. If it is going above, then green. If it is below, then gray. So let me share, this is what I have, then I will kind of walk you through how we kind of got the solution. In this case, without like knowing the use case or the data, I just picked up our test data. I just used stored numbers to create the bar. So I have electronic sales for each stored number here on my bar chart visualization. I created a property, I called it p-value, and I gave it a value of 24,000. So in this case, you can see all the bars which have value more than 24,000 are colored red based on this value. So if I decrease this value to 8,000, see more red coming in. So there are like more values exceeding that global benchmarking. So for global benchmarking, what I'm using is I'm using a property. Let me take it back to 24,000 and then show you these values. Then what I'm doing is I'm using a calculated column. So what I did was I created a calculated column. So I have a calculated column here, which is like location average, what I did was I just had an average electronics for each stored location. Now, based on how your calculation is, how your mean for each day is calculated, so I wanted to show you that whatever your calculation is, that can be grouped by another variable. So, for example, in this case, I have grouped it by stored location, so it's different for each stored location. So in your case, if it is average or some mean by each day, so this would be over that day column. So you will be able to get your calculation by that. So what I'm doing is, so I have two pieces here. I have a calculation, which is from my data, which is grouped by another variable. I have created a document property. So let me show you this document property. So this property is p-value, and I have created it as an integer. Now this document property, in this case, I am entering it from a user interface. It could be coming from a script, it could be coming from another sources. So your global variable has to be stored in a document property. The way it is updated could be multiple. It could be updated by manually entering these values the way I am showing you, but there could be other ways also by which you are actually updating this value. It could be coming as a calculation from another data table also. So once I have this global value, once I have my calculation, now let me go back to what I want to do here is if something exceeds that global value, red. If something is less than a particular value which is coming from my data, green or gray. So what I'm doing here is I will be kind of using a color by. So what I'm doing is I'm using expression on color by. In this case, I'm using a nested if statement. So if electronics is greater than p-value, give me 1. If it is greater than the average, the calculation, the calculated column, which I have by that particular value, give me 0 or -1. So I'm just getting 3 tags. If something is this, a tag of 1. If something is less than this, tag of 0, or something is greater than this, tag of -1. Now, another thing which is very important to note here is you need it to be a continuous mode. So by default, usually color by is categorical, and if you color by anything, you will see less than and greater than brackets around it, which kind of keep it as a categorical. But what I wanted is I wanted it to be continuous so that I can see 3 distinct values. So I can see -1, 0, and 1. Then I used color mode as unique values, and then I said whenever it is -1, say gray, whenever it is 0, green, whenever it is 1, red. So every time if my data, underlying data is changing, my calculation would change. Based on those values, you can see a difference in numbers. If I'm changing my global property here, which holds my p-value, I would see my kind of bars responding. So that's how whenever I change this, you would see more bars kind of coming up to be red. But in this case, since my data is static, you won't see any difference between 0 and 1 unless I change any aggregation or I make it a different calculation. Then you would be seeing the grays and greens kind of changing. So this was the first question for today. Let me pick up the second question. So in this case, we received, this question, we received part of it through support also. The issue was the DXP file was working on certain browsers, and for other browsers, it was not working. And the resolution was, we tried to kind of, on our end, the support tried to kind of check it on various versions if there is an issue with the browser compatibility. But the problem was with the time and date settings. So that's why there are like multiple questions which I have received for date and time. So in this case, what I want to focus is that there is a system date and time setting. So you can see for me, my system date and time setting is here. So depending on what format you have, your certain date calculations. So if you're using your date calculations in a script or somewhere, depending on your date and time format here. So I might be changing my date and time format. I may be in a different time zone. My short date format may be different depending on which operating system I am using. So in this case, your operating system is important. So whichever operating system you are using, what are your permissible? So it matters more when you are not all based US. You are based on different countries, so following kind of different date and time formats. So we pick up values from your system clock, so that's the date and time you are picking. And usually, if your script involves picking expressions like date, time, now, those you might see a different format. So in that case, when there are calculations which are using different formats, there may be a mismatch. So that is one of the reasons. Another kind of issue which I found was with date time now. So you want to calculate date time now, and then you want to compare it last 3 months, and every time you open the same analysis, your date time now should change. So in terms of creating a calculated column which involves date time now, it is simply I have this date function. I can see I have a date time now function, and I can insert this function, and it would kind of give me whatever is my current date time. And you can see sample result is 3/14/2017, and exactly 9:32 would be the time. So it would give me current date time now. Now, for me, it was like, if this is so simple, there might be something else happening with the customer, but that why we are not able to kind of see that date time now. So I have to give it a column name. So I can give it column name as test, and I can click OK. You don't see that coming up here because that test column I have not kind of added. So I can see the test column. So you can see that column is also added. I had one column already created here. Now, what I found in this case was that there was in Spotfire, an old version of Spotfire 5.5. I'm not sure whether we are using, the customer was using an old version of Spotfire 5.5 or maybe other. There was a hot fix which was basically, if you are using date time now with fiscal year, if you're using these two together, it used to kind of terminate the Spotfire session. So in this case, if you are using date time now in combination with fiscal year and you have Spotfire 5.5 version, which is a really old version, then there is a known issue where Spotfire would terminate and there would be a crash. So there is already a solution for that. So there is this hot fix which is already available, and that hot fix would kind of help fix that error in Spotfire 5.5 version. But Spotfire 5.5 version is a very old. That's the only use case we are aware where this would happen. But in case you have something where you are using fiscal year and date time now together, and you see a crash and your version is not 5.5, feel free to open up a support ticket. So they will be able to test why that is happening. Then another thing we have with same date time now is the date time now is something which can use. There was a question how to execute an iron Python script on initial load of an analysis. So Spotfire can have iron Python scripts, but they need something to be executed. So they need a button to be executed. But in case you want to kind of create a script which which should not have a button. The moment you kind of open up your analysis, that's the time that script should be kind of executed. This date time now, it comes in very handy. So what we have is, so whenever we create a property, so if I go to edit document properties, any property, whether I'm creating a document property, so whenever I create a document property, what we have is a script option. So we can tie, so for example, this property, I can tie it to a script. So if I click on that script, I can say, oh, this property should, every time the property value changes, there should be no action. Or every time the property value changes, this kind of script should be executed. So here I will add my IronPython script. So every time this p value changes, that IronPython script would be executed. So that's one piece of it. So I made a script which is executable without a button using a property, where the property would change. Now, in this case, how do you want to change the property? That's where this dateTimeNow function comes handy. So what we can do is, whenever we are creating the property, so whenever I'm creating a property, I could name this property, and I could have this property change value based on a calculation. So let me go here. Say, for example, I have this property here. So I'm trying to edit the text area. It's usually with WebEx, like it takes some time. Let me create a new property. So still I will have to insert a text area. Yes, so I will create a property. So for example, in this case, I am kind of picking up value, or I'm having it as a label. So let me have it as a label. Let me create a new property. Let me call it test. So right now it has no value, it is a string. Now, when I have string value, I'm not able to kind of give it a, so what I should be able to do is, I will be able to assign kind of calculations to this property. So with string type, I don't have set property value. With other types, I would be able to kind of set property values. So for example, if I say input field, if I have string, or I click on a drop-down list, I will be able to kind of give this. So usually label will not work for me, because I don't want it to be just, I want it to be selection. So in order to create, I will always use a drop-down list for this. And then I would see that there is a property selection here. So you can have unique values in column, you can have expressions. So I can use expressions there, and then I can type my expression as dateTimeNow function. Now, I may delete that text area, but even if the text area is deleted, even if that drop-down does not exist, this property will still stay there. So let me give it dateTimeNow, so I can use dateTimeNow function. So I have display name as same. It's a drop-down which is just one value, dateTimeNow, and I can click OK. So I have a dateTimeNow drop-down. Now, even if I delete this text area, it's just this text area I'm using to create that property. So that's why, like, the label will not work. I need a drop-down list by which I can pick different expressions. So in my case, I just have one expression. And I can kind of close this text area. So even if now I go to document properties, in my properties, I can see that test dateTimeNow still exists. So now this dateTimeNow will change value. So every time you open this file, you will be seeing that dateTimeNow will change value. The moment it changes value, since you can attach it to a script, the moment it changes value, your IronPython script will be executed. So this would be a nice way where this dateTimeNow function kind of helps you to make an IronPython script which can be executed during initial load of an analysis. So that's why, since all these were relevant to dateTimeNow and date functions, so I kind of clubbed them together. Now we have another question, which is, which is from the community, and that is something which relates to custom expressions. So let me open the file. We have this order sample which was shared with us. This is the file where we want to create difference. So as the way I understand it, we want to create the difference between central and east, central and west. So we want to create a difference between this first node. Now the way it took me some time to kind of even understand the question. It's basically your first node will not work because your first node will always kind of talk about first node as, so let me open this file. Your first node will always say this is the first node. So this particular bar is your first node. So whenever you are kind of, irrespective of your hierarchy, your first node, if you're using your first node in the calculation, it won't work because it is always the first node will be the one which is the first value. But in this case, your first node is changing every time this hierarchy is changing your order priority. So the way I understand is your first node for urgent order priority is central and this value. Your first node for urgent priority high is this value. So we do have these out-of-box calculations. So for example, if I have a bar chart, so what I mean by, and I have this as any value, so by each region. Now what I can do is I can calculate gross profit. So I can have total gross profit. I can use, instead of this aggregation, I can use any of these out-of-box aggregations, and I do have one aggregation which says change relative to start. So when I say change relative to start, it kind of picks up the first node, and then it kind of gives me this expression, and I can see this is the change relative to gross profit. With central, it is 0, with east, it is this much, and with west, it is this value. So it is change relative to start, but within each region, if I add each, say, plan number or each ship method, so I'm adding another hierarchy, again, your starting point is this. It is not here, it is not delivery truck. Your starting point is only this. So that's how the first node works. It always picks up a first node, only one node, not within that visualization multiple nodes. Now there is another one which kind of says change relative to a fixed point. Again, in terms of start, you specify which is your start, which is whatever your visualization has a starting point, you specify that. But in a fixed point, again, it's only one point. It is not anything which changes. It's only one point. I can say whenever it is central or delivery truck, I can change this delivery truck to express here. My fixed point may not be the first point. It may be somewhere middle. It may be somewhere here. But throughout this visualization, it will be only that single point which will be used. That's why whenever you were trying to kind of use first node, it was just like your first node is not a single node. It is more like changing value. Now there on the community page, you can already see we already have a solution which is kind of posted. So this is the question where you want to calculate east minus central, west minus central for a particular plan. And this is how you want your calculation. So there is already an answer kind of specified here where you can have gross profit if region is min region. So by min region, we are using alphabetic sorting. So we are saying the min region is because C is alphabetically first, that's what we are using. And your first node is always going to be the first one. So that's why it should have default string sort. And then we are using intersect of two methods. Order priority is for hierarchy here and for all access.rows. So I will use this expression, but I will kind of make it more generic and kind of show you how we can kind of use this. So in this case, I will right click and say custom expression. So I have this, you're trying first node, so that's why the first node did not work. The intersect is definitely we require. So first I will start with sum gross profit over just using first node. First node access.rows. So sum gross profit minus the first node access.rows. So this is my expression. Other than a parenthesis, I first node is access.rows. I don't have one. So and these are kind of sorted. So this is the difference. Now here up till this point you're fine, but here your first node should change. It is still taking the previous one, which is the west of urgent priority, which is what you don't want. So you want some kind of grouping to happen here so that this will work. Now let me show you on a bar chart. So if I have a bar chart and I have order priority, and within order priority I have each region, and I kind of say I use this gross profit and I use first node. So custom expression. So I use minus sum gross profit. So I can use the first node. So I can search first node. Now in this case, it is my it's not my access.rows, it is my access.x. So I have some gross profit minus whatever is the first node. I click OK. So there are two, and this is sum, and I have everything fine. Okay, this is here. Sorry, I didn't close the aggregation. The aggregation has to be closed before. Okay, so this is some gross profit, and I can see this one goes here. I can color by order priority. So I can use color by order priority. And in this case also, what I have to do is here, I am coloring by order priority, but I don't have any values here. Here what I want is I want to be still able to kind of, in this case, it is still trying to use first node as central. Whereas if I create difference from previous node, it will take color, but for first node, it is always, even if I am kind of dividing my color region, I'm segregating by color region, it will still think about this as the first node. And since I have a different color for this order priority, and I don't have this available, that's why you can see in this case it will show all blank. So first node in any visualization would not work for your use case because you are not looking at first node, you are looking at a minimum region, minimum node for each order priority. So that's why this particular calculation will work. So let me now use that calculation. So right click, custom expression. So this is the calculation. Now this is gross profit. This would be if region equal to minimum region. Then we have to have gross profit over intersect of order priority. Now in this case, instead of order priority, I could easily use parent. So I don't know whether order priority is my hierarchy. I could easily use parent access.rows. So I could use order priority, or I could use parent node function, and then I would use that with access.rows. So I can use parent, which kind of specifies that whoever is the parent, whoever is one level up in the hierarchy for that node, that is the one you are trying to kind of use. So you can see every time the parent changes, your minimum region changes. So the reason we are using intersect of parent is because we want this min region is not our first node. We want this min region to change every time the parent changes. So what we have is here 0, next value, and then we kind of want to kind of restart from here. And that's why you are able to kind of see, in this case, east minus central, west minus central. So this is the way your data was, and it required this calculation. But if I was supposed to do this calculation, I was supposed to do because because the second requirement for in this case was that you want to kind of come up with something which is a calculated column, which is again there is a formula, and then you want to create a graph. I would always kind of, I don't know how your actual data looks like, because this is more like a synthetic data which we use during our Spotfire training. So this, if I was supposed to do it, I would always insert a transformation. So what I would do is I would add a data table. I would add a data table based on existing table in my analysis. So whatever data table I have right now, based on that, which is this order table, I would call it order transformed, because that way I don't have to do any complex calculation. I would be able to easily get the difference. I would say order transformed. And I can use pivot. I can use multiple, like the way I want. I can use pivot. I can say for each plan. So for each plan, for each order priority, instead of having region, I would have region at the top. So I will have this region, and my value may be gross profit. So I have for each plan number, for each order priority, I have this gross profit. I have gross profit for all of them, and this is C, so I can give a naming pattern where I see central. So I have central, east, west. I can say central profit. So this kind of gives me that cross table. And now it is like another table. And what I can do is I can simply say east minus central, that's the difference. West minus central, that's the difference. I can have 2 more columns. And the moment I click OK, I have this data table, which is each of the plan, each of my order priorities, and I have an aggregation, which is total central, east, west. And now I can easily say I want west compared to central, so I can insert a calculated column and say I need a calculated column, I need west. My calculation becomes a simple plus minus calculation. West minus central, I could call it difference for west, and I can click OK. I don't have new columns added automatically. I can add them and say this is that calculation. So I have for each high, however it is. And then further, when I want to group, I can again unpivot it or kind of change it and see those values. So I can use transformations to get them converted into multiple data tables, and then based on what visualization I require, the changes can be made. So that would be way I would kind of make my calculations easy. But if you want to continue with the same kind of data form, then this would be the way to do it. So any questions on chat or anything related to this?
So I just wanted to point out a little bit about dashboarding over here. So if you look at the current page, you can see that even though we don't have a lot of information, like we have 6 plots, but all of those plots are minor plots. They're not things that you need to study in detail. You can just skim over them and sort of derive all the important information from these. But just a note about a few visual best practices. You can see all the axes, you can see all the titles and so on. So in order to consume the information better, it's always recommended that you auto title or title based on meaningful terms rather than just the aggregation. Clear out all of your axes. It's a good thing that the legend is not here. But what you could do is you could color by order priority. So that way, you don't have to see the label 1 urgent or 2 high. Your mind creates like a visual remembrance with the color codes. So just a few pointers here about best practices in dashboarding.
So we have a community article on visual design and dashboarding. So DJ, if you can share that with the audience. I do have another question for today, but I think we are running out of time. Because that's more like a detailed question. So it's more about the process. It's more about how to create control lines for process control. It is about, again, custom expressions and moving averages. I would kind of take that question for the next Spotfire session, kind of talk about more about control lines. We also have on our community a new auto encoder template, which we kind of released just yesterday. So this is a new template we kind of released. This is anomaly detection template for TIBCO Spotfire, and this has been just released yesterday. It has a detailed, so you can kind of download this release. You can kind of see. You can download it from here. There is a community article about this template on our wiki as well. So you can kind of go through, which kind of provides all this reference information, that what are the use cases for anomaly detection, what are the techniques which can be used. Then this auto encoder is kind of explained, then where it can be used. So this is something which is kind of latest, and we will, in future sessions, we will kind of have a featured session on this. So feel free to kind of ping us if you are interested. So more people are interested in this kind of featured session. We will have that up there as soon as possible. So I think that's all for today.
Yeah, just a quick note before we sign off. In the chat, I have sent you all the resources, including the data write-ups about the geoanalytics that we used up in our initial data exploration through maps. Feel free to give it a try. Definitely try out the template and let us know your feedback, and we look forward to seeing you next session.
Thank you. Have a good day.